Hello everyone, welcome to Technical Campus. And we have already completed the topic indefinite integrals, the method of performing integration, and we have also learned some basic formula of integration. And among those basic formula, these 13 formula are the most important formula for performing integration. So once again, I want to tell you, please remember this 13 formula, okay? Because if you remember this 13 formula, you can cover almost all type of question of integration, okay? And in the gate syllabus of calculus in integration portion, with the help of this 13 formula we can solve almost all the question of integration. So these 13 formula are very important in the gate point of view, so please try to remember these 13 formula only. All these formula are very simple, and we have also learned how to get this formula from the concept of differentiation. So please try to remember this 13 formula in order to solve the question based on integration, because these 13 formula are very important. So please note down this formula and try to remember all this formula. Now we will start the portion definite integrals, and then after finishing the portion definite integrals we will start solving the previous question of gate. So let us learn about definite integrals, okay? So let us understand the concept behind definite integrals. Suppose we have a function phi of x, and if we differentiate this function, we will get a new function f of x. Now the process of getting the function phi of x from the function f of x is known as integration. Or we can say, in order to get the function phi of x from the function f of x, we have to integrate the function f of x. If we integrate the function f of x, we will get the function phi of x, because integration means antiderivative, or the process of inverse differentiation is known as integration, okay? So if we integrate the function f of x, we will get the function phi of x. We have studied about this in the concept of indefinite integrals. In the concept of definite integrals, we have to just specify the boundary of integration. That means if we define the range of integration of this function f of x, if we define the boundary of integration for this function f of x, then the concept of definite integrals will come. So let us understand this concept by graphical way. Suppose we have a function f of x whose graph is like this, okay? So this is x-axis and this is y-axis. Y is equal to the function f of x, okay? So this is the graph of the function f of x. Now suppose this point is, consider a small element of this graph, that is, suppose this length is dx1, okay, and this height is corresponding to the height of y, that is f of x. Now suppose this height is f of x1, okay. If we consider the small element, then this portion is somehow look like a straight line. So you can notice that this is a rectangle. So if we want to calculate the area of this rectangle, then the area will be f of x1, that is this length, into this width, that is d of x1. So in the case of integration, basically we are considering small element of this graph, and we are taking area and we are adding them up, okay? This is the main working rule of integration, okay? We are taking the small element, we calculating the area, and we are adding them up. So if we keep on taking the small element and calculating the area, and we keep on adding the area, we will get the area under whole curve, okay? So this is the process of integration, okay? So while dealing with integration, we must take a continuous function. Fx must be continuous, because integrations deal with continuous function. And for discrete function, suppose we have a discrete function. Discrete means this function defined at discrete interval of time, okay? So in the case of discrete function, we will use the term summation. We cannot use the term integration. We have to use the term summation in the place of integration for discrete function. So let us leave this concept. So integration means basically calculating the area under curve, okay? So we have got a new definition of integration, that if we integrate a function, suppose this point is x is equal to a and this point is x is equal to b. So if we integrate the function between x is equal to a and x is equal to b, we can say we are calculating the area of this graph under x is equal to a and x is equal to b, because we have just learned that integration means basically calculating the area under the graph. So if we define the range of integration for this function f of x from x is equal to a to b, then we will say we are calculating the area under this graph from x is equal to a and x is equal to b. So we can write that if we integrate the function f of x dx from a to b, this is the way to write. Okay, this is the way to write, or this is the way to represent the definite integral. So if we integrate this function f of x from a to b, we will calculating the area of this graph of this function f of x from x is equal to a to x is equal to b. Okay, so we are basically calculating the area of the graph f of x under x is equal to a to b. Okay, so let us learn how to write the expression of definite integrals. Okay, so suppose we are defining a function f of x and the integration of f of x is phi of x. Now if we defining the range of integration, that is, suppose we are integrating this function from a is equal to b, then we will get a value corresponding to a equal to b. So we will say that the definite integral of function f of x over the closed interval a and b is denoted by this. Okay, this interval is closed because the value of a and b is included. This value of a and b, x is equal to a and x is equal to b, these both values are included, so we will consider this as a closed interval. That's why we are taking the third braces. Okay, so this is the way to write a definite integrals, or this is the expression that we are taking the definite integral of this function f of x over closed interval a and b, and this is the notation. Okay, so this value will be equal to ab f of x dx is equal to, in the place of x we have to replace by upper limit and lower limit, so it will be phi of b minus phi of a. So let us clarify this concept. Okay, so we have just learned that integration of f of x from a to b can be written as phi of x a and b. Okay, so is equal to, this means the value of function phi of x at x is equal to a, sorry, the upper limit, that is b, minus the value of this function phi of x at x is equal to b. Okay, or we can say from the concept of integration, that is value of antiderivative at b, that is the upper limit, minus value of antiderivative at a, that is the lower limit. So this is the theoretical concept of definite integrals. Now let us learn how to perform definite integrals. Okay, take an example to understand the concept of definite integrals. Suppose we have a function x square dx. In the case of indefinite integrals, the result of integration will be x to the power 2 plus 1 divided by 2 plus 1, because from the formula xn dx, the formula is x to the power n plus 1 by n plus 1. So if we apply this formula, so it will be x to the power 2 plus 1 divided by 2 plus 1. So the result will be x to the power 3 by 3. So this is the case of indefinite integrals. Here the range of integration is not defined, so we are getting the result in the term of x. If we integrate this, getting the result in the term of x. Okay, suppose the function x square and dx, and if we want to integrate this from x is equal to 1 to 2, then the result will be, so the result is x cube by 3, and we have to consider the upper and lower limit here. So we have to check the value of this function at x is equal to 2, and we have to subtract the value of this function at x is equal to 1. Okay, so if we replace the value of x, so basically we can write x cube by 3 at x is equal to 2. We have to take this value and we have to subtract this value from x cube by 3 at x is equal to 1, because this is upper limit, so we have to subtract the value of upper limit from the lower limit. Okay, so let us see how to perform this. So here the value of upper limit is 2 and value of lower limit is 1. So if we replace the value of x by upper limit, so it will be 2 cube by 3, and we have to subtract this by the value of the lower limit, that is if we replace the value of x by 1, it will be 1 cube by 3. So it will be 8 by 3 minus 1 by 3, that is 7 by 3. So this is the answer. So this is the way we have to calculate the value of definite integrals. So you can see in the case of definite integrals we are getting a numerical value, but in the case of indefinite integrals we are getting the result in the term of x, but here we are getting a numerical value as because we are defining the range. So we can say the area of the graph of x square from x is equal to 1 to 2 is 7 by 3 unit. Okay, so basically we are calculating the area of this graph from x is equal to 1 to 2. Okay, let us take some more example. Let us consider we have a function 1 by x dx, and if we want to integrate this function from x is equal to minus 4 to x is equal to minus 1, this is upper limit and this is lower limit. So you have to say that we want to integrate this function from x is equal to minus 4 to x is equal to minus 1. So this value will be simply the integration of 1 by x is log x, and if we apply the limit, that is minus 4 to minus 1, so by applying the limit it will be log of upper limit is minus 1, and we have to subtract this from the value of lower limit, that is minus 4. So as this is under mod, so it will be log 1 minus log 4, and the value of log 1 is 0, so it will be minus log 4. This is the answer. So let us take one more example. Okay, suppose we have a function 1 by 2x minus 3, and if we integrate this from 0 to 1, so it will be, if we apply the rule of integration by substitution, so this value will be 1 by 2 into log 2x minus 3. So please solve this integration by applying integration by substitution. Okay, so if you apply the rule you will get this value. Now if we apply the limit, in this case it will be, so this will be under mod. Okay, it will be half into log, if we put the value of 1 here it will be minus 1, and if we put the value of x is equal to 0, so it will be minus log of minus 3. So the result will be half into log 1 minus log 3. So log 1 is 0, so the value will be minus half into log 3. So this is the answer. So in this way we have to perform the definite integral operations. So let us solve some question of GATE from this topic, integration. Okay,